had a hard time doing the long division? Especially if you're finding out if there's a remainder or not? I do. Well, today's your lucky day. We will be tackling about the divisibility rules of 2, 3, 4, 5, 6, 8, 9, 10, and 12. Let's get started. Before we learn about the divisibility rules, let us first find out what is a divisibility rule. Wikipedia defines a divisibility rule as a shorthand or easy and fast way of determining whether a given integer is divisible by a fixed divisor without performing the long division, usually by just looking and examining its digits. First, we have the divisibility rules for 2 and 10. Why did we jump to 10, you ask? That is because the divisibility rule of 2 and 10 are almost the same. The divisibility rule of 2 states that if the last 2 digits of the number is an even number, or should I say ends with 0, 2, 4, 6, or 8, the number is divisible by 2. For example, 394. 394 is divisible by 2 because it ends with 4, which is an even number. We also have the divisibility rule of 10. Just like 2, we could know if the number is divisible by 10 by just looking at it. The divisibility rule of 10 says that the last digit of the number must be 0 and 0 alone. An example of a number which is both divisible by 2 and 10 is 630. If you said this is divisible by 2 and 10 for its last digit is 0, you are correct. If a number is divisible by 10, automatically it is both divisible by 2 and 5 as well. Because for the divisibility rule of 5, the number must be 0 or 5. In this example, we have 185. 185 is divisible by 5 because its last digit is 5. We also have the divisibility rules for 4 and 8. Just like 2, 5, and 10, they almost have the same concept. The divisibility rule of 4 states that the last 2 digits of the number must be divisible by 4. Take, for instance, 728. 728 is divisible by 4 because its last 2 digits, which is 28, is divisible by 4. While the divisibility rule of 8 is somewhat like the divisibility rule of 4. But instead of looking at the last 2 digits of the number, the last 3 digits of the number must be divisible by 8. An example is 9,264. 264, which is the last 3 digits of the number, is divisible by 8. Next up, we have the divisibility rules of 3 and 9. The divisibility rule of 3 points that the sum of all the digits must be divisible by 3. An example is 916,455. 9 plus 1 plus 6 plus 4 plus 5 plus 5 is equivalent to 30, and 30 is divisible by 3. And it will have no remainder. The divisibility rule of 9 is somewhat like the divisibility rule of 3. The sum of all the digits must be divisible by 9. An example of this is 62,334. 62,334, when all added up, the answer is 18, and 18 is divisible by 9. Last but not least, we have the divisibility rules for 12 and 6. The divisibility rule of 6 says that it first must be divisible by 2 and 3. Example, 732. 732 ends with an even number, and when all added up, the sum is 12. So it is both divisible by 2 and 3. The divisibility rule of 12 says that the sum of all the digits must be divisible by 3 and the last 2 digits must be divisible by 4, or it must be both divisible by 3 and 4. An example is 132. 132 is divisible by both 3 and 4 because when all added up, the sum is 6 and it is divisible by 3. And its last 2 digits, which is 32, is divisible by 4. Were you able to understand all of it clearly? Let's answer the following to find out. All we have to do is to list down the numbers it is divisible by. And don't forget to apply the divisibility rules. First we have 312, second is 6,480, and third is 18,245. 312 is divisible by 2 since it ends with an even number. Divisible by 3 because the sum of all the digits is 6, which is divisible by 3. By 4, by 6 because it is divisible by both 2 and 3. By 8, and by 12 since it is divisible by 3 and 4. 6,480 on the other hand is divisible by 2 since it ends with 0, which is an even number. It is also divisible by 3, by 4, by 5 because it ends with 0, by 6, by 8, 10 ends with 0, and 12. And lastly, 18,245 is only divisible by 5. It is divisible by 5 because it ends with 5. I hope you did great in the short activity. Now let's answer this word problem. A vaccine supplier wants to donate equal amounts of vaccine doses to various small barangays. The more doses to give, the better. How many barangays could she equally donate to if there are 18,036 doses of the vaccine? How many doses will each barangay get? 18,036 ends with an even number, which is 6. So it is divisible by 2. And when 18,036 is all added up, the answer is 18. So it is divisible by 3 as well. Divisible by 4 because 36, which is the last 2 digits, is divisible by 4. It is not divisible by 5, nor by 10 because it does not end with 0 or 5. But since it is divisible by both 2 and 3, it is also divisible by 6. Not divisible by 8 because its last 3 digits is not divisible by 8. But it is divisible by 9 because the sum is 18 and 18 is divisible by 9. And it is also divisible by 12 because again it is divisible by 3 and 4. Among all of them, 12 is the biggest number. 18,036 divided by 12 is equivalent to 1,503. And therefore, each of the 12 barangays will receive 1,503 doses of the vaccine.
That's all for now. I hope you all learned something in this video. Don't forget to like, subscribe, click the notification bell, and share. Para lahat tayo maging matalino.